for grade 10 advanced in term 2. So the first question maybe will be about the evidence of chemical change or chemical reaction. So to know that this is a chemical reaction or chemical change, we have many evidences. The first one is change in color. The second one is a change in temperature. The third one is gases or bubbles, okay, production. So let's see the first example. As we see here, we have a question from previous years, previous exams. The first one, which figures illustrates evidence of chemical reaction. As we see, we have here the first one, which is about banana changing from green to yellow. The second one is fireworks. The third one is water boiling, and the fourth one is chocolate melting. So the first one we have here a change in color. Okay, so this the first one is correct, which is banana change color. Okay. The second one here, we can see that we have here heat and light. So this is an evidence of chemical reaction. Here, this is a physical change because boiling, melting, evaporation, okay, all of them are what? Are physical changes, okay, because here we don't have a change in the substance itself. So the water will stay water when heating, and chocolate will stay chocolate when melting. So no change in the substance itself. Okay. So the correct answer is 1 and 3. So we choose 1 and 3 only. Okay. The second question in the figure below, what is the evidence that indicates a chemical reaction has occurred? So as we see here, we have a change in color. As we see, we add the first substance, the first reactant to the second one. So there is a change in color. So we choose the color change. The second type of questions is about balancing chemical reaction. In balancing chemical reaction, the reactants and products should be equal in the number according to the number of in terms of the number of atoms and the types of atoms. So here we can use the elimination method to cancel out the incorrect answers or options. So as we see here, they said here sodium, solid sodium, Na, okay, reacts vigorously with water, which is liquid, okay, that yields gases hydrogen H2 and solution of sodium hydroxide. So that means that the reactants are Na and water. Okay, so they will yield or produce or give H2O, H2 gas. So this is gas. Okay, but what about the sodium? Sodium here is solid. So this is the physical state here is solid. Here water is liquid. So this is liquid. Okay, and this one is solution. So we have here AQ. So let's check the answers here before answering the questions here. So the first one here, let's see, Na solid. That's right, Na solid. H2O is AQ, aqueous solution, but H2O is liquid. So that this one is not correct. So we can cancel this option. Okay. Look at the second one. We have here 2NaOH, which is AQ. Yeah, NaOH is AQ, but NaOH should be in the products, not in the reactants. As you see, NaOH is in the products, not reactants. So we can cancel this. This is not correct. Third one, 3NaAQ. Okay, but they said here that Na is solid, so we can cancel this. So as you see, when using the elimination, just trying to find a mistake, any mistake in the options, so it will lead us to the correct answer. But let's check the correct answer. Na here we have 2Na. In the products we have 2Na, as you see, because Na will be multiplied by the, because this is a coefficient. Okay, so this is a coefficient, so it will multiply by all the atoms here. So we have 2Na, we have 2Na. Okay, 2 times 2, we have 4H. 4H. Look here, we have here 2H 2H, and here we have 2H, so we have 4H. What about oxygen? We have here 2 oxygen, and here we have 2 oxygen. So all of them are equal. Okay, so this is the correct answer. Okay, so let's move to the another example. What is the correct balanced skeleton equation that represents the chemical reaction between hydrochloric acid, this hydrochloric acid, okay, reacts with solid aluminum. So aluminum here is solid, so this is a solid. They will react to produce or to yield aqueous aluminum chloride. So aluminum chloride is aqueous. So this is AQ. Okay, what about hydrogen? But hydrogen here plus hydrogen is a gas. So hydrogen is a gas. So let's see. We have HCl, which is AQ. Okay, and we have solid aluminum, which is S, to produce AlCl3 and H2, which is hydrogen gas. Okay, so the reactants are HCl and Al. The products are AlCl3 and H2. And you have to, to have a look on the physical state. Okay, so let's see. Al solid, yeah, Al solid plus HCl gas. No, HCl is not gas. HCl is aqueous, AQ. So as you see, this is a mistake. Let's go through the first option. As you see here, they said here AlCl3, which is liquid, but AlCl3 is AQ. So this is another mistake. H2, which is AQ, but H2 is gas. Okay, so totally this option is not correct. Let's move to the second one. Al is solid. Okay, Al is solid. Yeah. HCl is AQ. HCl AQ. Okay, 2 AlCl3 AQ, 2 LCl3 AQ. Yeah. H2 gas, H2 gas. This is maybe correct, maybe not correct. Okay, so let's move. AlAQ, they said here Al is solid, so this is not correct. Okay, at all. HClAQ, yeah, HClAQ. AlCl3AQ, HClAQ, but this one is not correct. So this one at all is not correct. Okay, let's move here. They said AlCl3 will react with H2. So that means they are the reactants, but here they are the products. So this one is not correct. Okay. So as you see, this is the correct option, but let's check. We have 2Al, we have 2Al. Yeah. 6H, 3 times 2, we have 6H. Okay. 6Cl, 6Cl. So we have here 2 times 3, we have 6Cl. So that means that this is the correct option. Okay. Now we'll move to the next types of questions. Next type of questions, which speaks about the types of reactions. So we have 5 types of chemical reactions in here in our curriculum. Okay, the first one is synthesis, which means combination. Combination, which means that we have 2 or more reactants. They will combine together to form one chemical or one substance. So in the reactants, we will face 2 or more reactants. They produce only one. Okay, this is the synthesis. The second one is the decomposition. Decomposition, which is the opposite of synthesis. So that means here we have one compound, okay, which will break down into 2 or more substances. Okay, so the combustion, how to know that's combustion? Combustion means burning. Burning, you will see it before the arrow in the reactants, we have oxygen gas, which is O2. Single replacement, how to know that this is single replacement? We have element, compound, element, compound. So again, in the reactants, we have element and compound. And in the products, we have element and compound, as you see. In the double replacement, we have compound, 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 compound. So in the reactants, we have two compounds, and in the products, we have 2 compounds also. Okay, so these are the main 5 types of chemical reactions in our curriculum. Okay, here in the single replacement, A, for example, will try to kick out B. Okay, so if A is more reactive than B, so B will be kicked out, and A will take the place of what? Of B. Okay, so it will produce AX plus B. This is in the single replacement. In double replacement, just we replace or swap between X and Y, or A and B. Okay, so if we swap between X and Y, so A will get Y, B will get X. So this is the double replacement. Let's move here. This is the first question. Which of the following is a single replacement? As we say that in the single replacement, we have element compound, element compound. Okay, in the reactants we have element compound, and in the products we have element and compound. And we can focus on the the process of the single replacement. So look at the first one. This one here we have oxygen before the arrow. If we have oxygen before the arrow, so this is what? This is combustion, burning. Okay. The second one here, let's check this second one. We have element, compound, element, compound. So this is what? This is a single replacement. And you can check here, look at Cu. Cu kicked out what? Kicked out Ag. So Ag is out. Okay. But look, Cu sits here in the place of what? Of Ag. So as you see, Cu and NO3. Let's move to the third one. Third one here we have oxygen before the arrow. So this is a combustion, and you can see we can say that this is also the synthesis reaction, because here we have two materials, two chemicals. They combine together to form only one. So we can call them, or we can categorize this reaction as synthesis, since we have two chemicals, they combine together to form only one. Okay, and we can say that this is what? This is combustion, because we have oxygen before the arrow. Look at this. As you see, compound, 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 compound. So this is what? This double replacement. So that means there's they ask me about the single replacement, so we choose this. Next question. What is the reaction of a substance with oxygen? Okay, so there's a reaction with oxygen. So that means the oxygen will be in the reactants. So this is what? This is a combustion, burning. Okay, and look here, they say and releases energy to form heat and light. So this is another evidence that this is what? This is a combustion reaction. The next question, which one of the following chemical reaction equations represents synthesis reaction? As we said, synthesis means combining, okay? So let's see here, we have one chemical, this is the second one. They combine to form what? Only one. So as you see here, we have two or more compounds, or let's say chemicals, okay? They combine together, only one. Okay, so this is the correct answer. Let's check the rest of the options. Here we have oxygen before the arrow, so this is combustion. Here we have compound, 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 so this is double replacement. Look at this. Here we have only one chemical, but here it breaks down into 1, 2, 3 chemicals. So that means this is a decomposition reaction. Okay. Another example, what is the type of the chemical reaction presented by in the equation below? AB produces A and B. As you see here, we have one chemical and this chemical breaks down into two or more. Okay, as you see. So this is what? Uh, this is a decomposition reaction. Okay. Let's move to the next point, which speaks about what is the total number of atoms in 0.645 moles of a sample of argon gas, AR. Okay, so to convert from mole to atoms, we multiply by what? By the Avogadro number, which is 6.02 times 10 to the power 23, which is given here. Okay, times 6.02, okay, times 10 to the power of 23, okay, particles over 1 mole. Okay, So by multiplying 0.645 times 10, mole times 6.02 times 10 to power 23, okay, over 1 mole. So we'll get the answer. Let's check the answer, okay? Just a moment, please. Here. Okay. We have 6.02 times 10 to the power 23. Sorry. We have 0.645 times. We have fraction here. 6.02 times 10 to the power 23, and down we have 1. Okay, so this is the answer, which is this. Okay. The next one, they need here, they want us to find what? To find the number of moles. Okay, so we have the number of molecules, which are number of molecules are particles. Okay, so to convert from particles to mole, we multiply by what? We multiply by 1 mole over the Avogadro number. This is the Avogadro number. Okay, so let's check. We have 2.5 times 10 to the power 23 times this fraction. We have 1, and down we have 6.02 times 10 to the power 23, okay, equals 0.42. Okay, so this is the correct answer. Okay, here they said we have 20 grams of CO2, and they give us the molar mass. Okay, so how to convert from and they ask me, okay, how many moles? How many moles? So how to convert from grams to moles? To convert from grams to moles, we just multiply by 1 mole over the number of grams in moles, okay, in mole, which is 44, okay, so this is the 44. So this is the molar mass, and this is the mass, okay, so let's check the answer. We have 22 times, and this is the fraction, and the fraction we have 1 over 44, sorry, 1 over 44 equals 0.5, so we choose 0.5 mole. Okay, let's move to this one. Also here they ask me how many moles. Okay, how many moles, and they gave me the mass, which is 82 grams. Okay, how many? Okay, so we'll follow the same step. Okay, so we multiply by 1 mole over the molar mass, which is 27. Okay, so let's check. We have 82 times this is the fraction. We have here 1, and here we have 27 equals 3.04. So this is the correct answer. Okay. Here, which of the following reactions in aqueous reaction produces gases? Okay, how to know that it produces gases? Because you know we have 3 types of products. Okay, the first one is the precipitate. Okay, so the first one is what? Is the precipitate. Okay, just a moment. So this is the first one. Precipitate. Okay. Sorry. The second one is gas. and the third one is water, which is liquid. Okay, and gas is G, gas, G. Okay, and precipitate is solid. Okay, solid. So we have three types of products in the double replacement reaction here. Okay, so precipitate, solid, gas, G, water, liquid. Okay, so this one here they said produces what? Gas. Okay, so let's check here. What do we have here? Water, liquid. This is the third type, okay, which is water. Here, what do we have? We have gas in the product, so this is the correct answer. Let's check this one. This one's solid. Solid, this solid, precipitate. Okay, and this one, by the way, this is not not an aqueous reaction in aqueous solution. Okay, so as you see here, because here we don't have aqueous reaction, we have we don't have AQ and AQ. Okay, so this is the correct answer. The third one. Okay, what is the type of the chemical reaction? This question was the type of the chemical reaction shown in the following chemical reaction equation. Sorry. So as you see here, what do we have here? We have S in the products. S solid. So solid precipitates. So we choose this one. Okay. Because if we have G gas, we choose this one. G. Water, we choose L. Water. H2O. Liquid. Okay. Here we have this question, this type of questions. Using the reactivity series of metals, what would yield the single replacement reaction of calcium and Ca and ZnNO3? Okay, so this is the reaction Ca and ZnNO3. So let's check. Where is Ca? Ca is calcium. Where is calcium? This calcium. Okay, and Zn, which is zinc. This zinc. Okay, so as you see, Ca is more reactive than what? Than Zn. So Ca will be able to kick out Zn. Okay, so Ca will kick out Zn. So what we get? We get here. We get here Ca plus Zn, which is paired with what? With NO3. Okay, I'm not talking here about writing the correct formula. Okay, I'm focusing now on what? On the reaction itself. Okay, so let's see. Where do we have Ca and Zn and NO3? This is the correct answer. Okay, this is the correct answer because here we have Ca and Zn and NO3. And by two, by the way. Sorry. No, sorry. I have a mistake here. Not this. Because it will replace. Okay, just a moment. I have try to collect it. Okay, so Zn will be out. Zn will be out. Okay, and Ca, this Ca. Okay, so Zn and CnO3. Okay, let's move to the next question. Using the halogen's reactivity series, what would yield the reaction of chlorine gas, which is Cl2, and aqueous hydrogen fluoride, which is HF? Okay, so let's check. We have here, Ca, Cl, and HF. So Cl is a chlorine. Okay, this is chlorine. And F is a fluorine. This is F, fluorine. Okay, so Cl is less reactive than F. Cl is less reactive than F. So Cl will not be able to kick out what? To replace what? F. So there is no reaction. No reaction. Okay, so now, how many moles of nitrogen atoms are contained in 1 mole of BaNO3? So he's asking me about what? About the number of moles of nitrogen. Number of moles of what? Of nitrogen. Nitrogen is N. Okay. In what? In 1 mole of BaNO3. So we have 1 mole of what? Of BaNO3 multiplied by what? How many moles of Na? Oh, sorry, Fn. Here we have 2, as you see here we have a subscript here, okay? Because we say here BaNO3 by 2. So 2 is multiplied by what? By n. So how many n do we have here? We have 2n. In what? In 1 mole of the compound. Okay. So 1 times 2 over 1, we will get 1. Okay. This is the solution of this question. Okay. So now, what is the net ionic equation of the following reaction? How to get the net ionic equation? You can break it down into ions and solve it and cancel out the spectator ions, but there is maybe, an easier way, to get the answer. So if they ask you about the net ionic equation, just go to the products, okay, and find uh, the chemical which is solid or liquid or gas. Again, to find the net ionic equation, we need to go through the equation, okay, to the products, okay, and try to find what? To find the solid or liquid or gas, not aqueous. So where's the solid or liquid or gas? This one, in the products. So break it down. What do we have? We have Ca and 2OH. Okay, 2OH. Okay, which will produce what? Produce this. Okay, Ca plus 2 and OH minus 1. Okay, so let's check. This is the correct answer. So this is what? This is the net ionic equation. Here, they said an ionic equation that shows all the particles. So all the particles, this is what? Complete ionic equation. Okay. What's the meaning of the spectator ions? Spectator ions that don't participate. Okay. Ions that don't participate in the reaction. What is the net ionic equation? We'll follow the same process. Okay. Net ionic equations. We will look for the solid or liquid or gas in the products. Okay. So this is the gas. So break it down. We have 2H plus 2Cn. Okay. To produce what? 2Cn to produce this. This is plus and this is minus. Okay. So to produce this. So where's the correct answer? This is the correct answer. The net ionic equation. And by the way, if they ask you about the spectator ions, just go to the products and choose what? Choose the aqueous. If they ask you about the spectator ions, just go to the products and break down the aqueous solution. Okay, you will get what? The spectator ions. Okay. Here, what's the percent by mass of sodium Na in sodium sulfate? Okay, how to find the percent by mass? Percent by mass is very easy. Look, the percent by mass. Percent by mass of what? Of Na. Okay, so let's check. This Na percent equals. How many Na do we have here? Because they are asking me about the Na, the sodium. Okay, how many Na do we have? We do have here. We have 2. Okay, times what? The molar mass of Na. This is the molar mass of Na. Divide by what? Divide by the total. This is the total. Or the molar mass of the compound. Okay. Then times 100. Be careful, huh? Don't forget the subscript here. Because let's check. You will see. Here, for example, if you forgot, okay, the 2 here, what will you get? Look. We will say 2, will not write 2, we'll write 23, okay? So 23 divide by what? 119, okay? Then times 100 equals, look, 19 point. The option is mentioned here, okay? Is written here, okay? So this is not the correct answer. So just be careful because here we have, as you see, look, we have here 2 times, look, we have here 2 times 23 divided by 119, okay, then multiplied by 100. So what do we get? We get this answer, which is 38.65. So this is the correct answer. So just be careful, huh? Don't forget the subscript. Okay. So let's move to this one. They ask me about the carbon. Okay. C. Where's carbon? This is the carbon. So what's the coefficient? Coefficient is 8. So 8 times molar mass of carbon. Where's the molar mass of carbon? This is the molar mass of carbon. Oh, sorry. Put it here. Okay. So this is the molar mass of carbon. This is what? This is the molar mass of the carbon. Over what? Over the molar mass of the compound. So let's find it. What do we have? We have 8 times the fraction. Sorry, we have fraction. Here we have 8 times 12 divided by 19194. Okay. And here, oh, sorry, times 100. Here we have to write times 100. This is the answer. Okay. 49, this is the correct answer. Here we have to multiply by 100 because this is a percent. Okay. This is the percent. Okay. This is the first part of our revision. Okay. Later, inshallah, we will have the second part, inshallah. Okay. السلام عليكم ورحمة الله.